Hi, I'd like to make two very short videos illustrating the ideas that we started in class yesterday. So remember, we're doing repeated, independent, identical trials. We're doing something over and over again. Each time you can either have a success or a failure. The probability of success is P. The probability of failure is 1 minus P, which we also call Q. And up until now, we've always known what P is. But in the course of the real world, we don't really know what P is. We'd like to be able to determine P. So when we're doing these repeated, identical, independent trials, we call those Bernoulli trials, and we end up with a binomial distribution, which we've already studied. And we're looking for a confidence interval for P. We're looking for an interval where we can say P is at least as big as this number and at least as small as this number. So P is sandwiched in between two values, P hat minus the error and P hat plus the error. Now P hat is when we do our independent trials, we count the number of successes, we'll call that R, divided by the total number of trials, we'll call that N, and that was its probability of success, its chance of success in the trials that we did. That's probably not going to be P exactly, but that's our best guess for P. And then to get the error, we usually need an error. We just take our confidence and take ZC, and then multiply that by P hat, Q hat, over N underneath the square root. Remember that Q hat, is nothing more than 1 minus P hat. Okay, so hopefully that wasn't too quick, but you can always rewind the video and have a look at it again. So let's take a look at an example. Say we're testing a new treatment for a skin condition. We test it on 200 people, and it works on 150 of them. So already in your mind, you should be able to see, oh, I know what P hat is. Because we tested it on 200, it worked on 150. Just make sure that in your head, you know what P hat is. And let's see, we want to give a 90% confidence interval for a probability that the treatment will work on a random person. So a random patient who has this condition. We want to try this treatment on them. We want to know what probability that this treatment will clear up their skin condition. So let's just write down the things that we know. So we know that C is 90%. And so we already know that ZC, I believe this ZC for 90% is 1.645. And we know our interval is going to be of the form P hat minus E to P hat plus E. So let's figure out what our P hat is. You probably already did this in your head. So the chance in our trial on 200 people that this treatment worked, it worked on 150 of them. That's our R. And we tried it on 200 people altogether. And if you like fractions, that's 3/4. If you like decimals, that's 0.75. And of course, Q hat is nothing more than 1 minus P hat. So 1 minus 0.75 is 0.25. So we're already almost there. All we have to do now is figure out what E is, and then subtract that from P hat and add it to P hat to get the bounds on our confidence interval. So let's see. E is going to be equal to ZC. So ZC 1.645 times the square root of P hat. P hat is 0.75. Q hat is 0.25 divided by 200. When you type this into the calculator, make sure that your square root isn't just over the numerator. Maybe I should be a little bit more explicit about how far down that square root goes. So when you're typing it in your calculator, you're going to put the square root symbol in, and then that'll open up some parentheses. You'll put in 0.75 times 0.25 divided by 200, and don't close the parentheses until after you put the denominator in, because it all goes underneath the square root symbol. And if I'm not mistaken, that approximately equals 0.050. So we're all set to write our confidence interval down. It's centered at P hat. Our best guess for P is P hat, which is 0.75 or 75%. So our confidence interval is 0.75 minus 0.05 to 0.75 plus 0.05. And that 0.75 minus 0.05 is 0.70. And 0.75 plus 0.05 is 0.80. This is 70%, of course. This is 80%. You can write it like that if you want. You can write 70% is less than P is less than 80%. And it makes sense that our best guess for P was 3/4, 75%. And it just so happened that this number worked out very nicely. A 90% confidence interval for P. We can be 90% sure that the true value, the true rate at which this treatment works across the whole population is between 70% and 80%.